good afternoon to all of you. Welcome on our EPFL campus. I'm basically heading the Transportation Center here at EPFL. Actually, we have a couple of multidisciplinary and interfaculty centers here at EPFL. And the idea is usually to gather the research laboratories we have around a similar topic. So we have an energy center, we have a transportation center, we have a social media center. And the transportation center was created back in April 2009, so 5 years ago. Nowadays, we are basically affiliating 39 laboratories that are coming from 5 different schools or faculties here at EPFL. Well, most of the labs are coming from ENAC because ENAC is the faculty that hosts civil engineering. And you might know that in most universities, either in Europe or in the US, that transportation is usually one of the topics that is hosted in civil engineering or civil and environmental engineering department. But we also have a couple of labs coming from the School of Engineering, the School of Basic Sciences, so where we have the labs in math, chemistry, and physics, and also the School of Computer Sciences and Communication Sciences. So as I said, we are not only interfaculty, but we are also interdisciplinary. So the idea is not only to focus on vehicles and infrastructures, but it's also to focus on topics that are related to transportation, including environmental aspects, energy aspects, economic aspects, urban planning and land use, mobility behavioral analysis. So we have a strong focus on demand-related transportation research, so everything that is related to mobility measurement, mobility analysis, mobility prediction. I'll show you some examples of concrete projects later on. Multimodality, so how to design in an efficient way multimodal transport systems, traffic monitoring, traffic optimization, ITS, so it's very broad. So it's a sort of 360-degree view on transportation. Before showing you some concrete examples of ongoing projects, I want to tell you a bit more about our missions and about the way we are working together with our research laboratories. So the main mission is to be an interfacing place. So basically, we are the one-stop shop for external partners that are interested in collaborating with EPFL in the field of transportation or mobility to the large extent. Meaning that we are interacting with public authorities, governments, associations, companies, so from the small local SMEs or EPFL spin-off to the large-scale multinational company, but also other universities to try to develop academic collaboration. As I already said, one of our main goals is to gather the competencies at EPFL that are spread over the different faculties and over the different institutes, the labs that are related to transportation. So we do not only develop the networking of our scientists outside EPFL, but we also aim at developing the networking internally. So to put labs in contact so that they develop synergies and collaborative projects, because you might know that I don't know whether you get a general introduction to EPFL, but EPFL is a big school. We have 360 labs, so obviously not each professor knows all the other 355 or 59 colleagues. So we're also there to find the synergies between the labs, putting together mathematicians with sociologists to analyze mobility, putting together experts in distributed robotics, optimal control, and computer vision when it comes to unmanned aircrafts, so all these type of things. To foster innovation through a multidisciplinary approach, so we try to have as much project as possible that involve several labs at once, and to reinforce tech transfer. So this is why I'm attached to the VP for tech transfer, so I'm reporting to our Vice President for tech transfer. We are really there to develop partnerships with public and private entities. So among our coordination activities, because we also aim at coordinating research activities and teaching activities in the field of mobility at EPFL, our main production, I would say, is to initiate large-scale projects with external partners. So today speaking, we have about 40 active projects involving 16 labs from EPFL. Average duration of 20 months, meaning that we have projects where we are associating PhD students. So here the timeline is rather from 3 to 4 years, but we also have shorter term research mandates from typically 6 months to 1 year, or some feasibility studies that are usually a first phase towards a longer term collaboration. So all these projects are conducted with external partners. So we are not there to, I would say, initiate and manage fundamental research projects. This is the duties of our labs. Our labs are there to do the fundamental science. Here we are there to initiate projects with external partners. So we are working with railway companies, public authorities, federal offices, car manufacturers, automotive suppliers, public transport operators, actors in the aerospace industry like Honeywell, so it's pretty diversified. Now I just wanted to tell you about the key success factors for tech transfer that are basically aspects that we have successfully implemented here for the Transportation Center. What is important to say is that at the beginning, it was a bottom-up initiative. So the idea of the Transportation Center was not decided by the EPFL top management. It was an initiative from two of our core professors in transportation, Michel Berler, which is a mathematician, so representing, I would say, the exact sciences side of transportation, and Vincent Kaufman, who is a sociologist representing the social sciences in transportation. And they were the two professors who decided to discuss with the top management about this idea of creating an interdisciplinary interfaculty center. And then we have a bicephalous governance, meaning that a center is not a research laboratories. The laboratories are doing research. At the Transportation Center, in my team, I rather have project managers, account managers, business developers. So we are there to provide competencies that are complementary and orthogonal to the lab. And I'm the executive director, while Michel Berler is basically the professor that who embodies the transportation topic at EPFL. And this is really important to make this clear separation. So Michel Berler has his own lab, which is one of the transportation lab, and I'm running the center. We have obviously close contacts and exchanging together on the strategy, but they are respective duties and respective objectives. And then it's an interaction with the top management. So it's an added value to be directly attached to the top management of the school. So my direct boss is a VP, and then the president is just above. So it's one way both to know about the strategy of the school, but it's also one way to convey the message coming from the scientists and coming from the lab. So it's a good level of in the structure, I would say. Now what we did at the very beginning is to define a roadmap, because it's good to gather 40 labs from different faculties, but we should know what we aim at doing in terms of transportation research. What are the key topics we want to develop, and topics that should have both scientific interest, but also potentialities for external fundraising, for industrial partnerships and collaboration. So we developed a global roadmap for transportation research that goes much beyond the couple of core labs in transportation we have at EPFL. So in this roadmap, we have aspects related to supply chain management, we have aspects related to intelligent vehicles, and many other topics. And it's important to have this capability to federate our labs and to reinforce the networking around a similar topic. And then what we need to do, I don't know about your background, but at EPFL, we have many of our scientists and many of our professors are afraid by external collaboration, because collaborating with external partners has some advantages. You have access to extra sources of funding. You have access to real data sets. You have access to real case studies. You have some real problems to be solved that bring motivation for generating research ideas. So these are the positive side. Then the negative side is that you have some deliverables you need to stick to. You need to manage the collaboration with this partner. From time to time, you need to do some crisis management. And these are things that our professors do not want to do or are not very good at doing, because they are mainly there to do research. So we are really providing this support from A to Z. So from the business development that is targeted towards the lab research agenda. So we are closely discussing with our labs to know about their research interest, to know about where they want to bring their lab within the next 2 years, 5 years, 10 years. And then we try to transform these research ideas into concrete projects that can be funded by external entities. So it's important to have a bottom-up biz dev and not just a top-down approach where we are just waiting for companies to contact us to evaluate opportunities for collaborating with us. It's also a work of filtering. It's filtering at best the opportunities that are generated thanks to a good knowledge of our lab's expectation. So each time a company knocks our door, we are not directly going to the lab and bothering the professor. We are first evaluating whether there is a potential for collaboration and whether the interest from these external partners are in line with our research interest. Then it's support in grant preparation, proposal preparation, contract and deal negotiation. And then once the project has started, it's all about account management, project management, crisis management, and eventually the promotion, the valorization, the visibility through websites, through press release, and so on. So we are really providing this it's support. So support is not a negative term. It's basically support to our research teams to be able to successfully initiate, manage, and finalize projects that are conducted with external partners. And these are the main factors that made the success of the Transportation Center over the last 5 years. I'm talking about this to tell you about how we are structuring tech transfer and what tech transfer means at EPFL. Now I'll show you more concretely about some projects and about some topics we are working on. I'll skip the challenges, you know about challenges in transportation, but the key thing at EPFL in terms of transportation is that unlike most of the universities and unlike most of the transportation center in different European universities, we try to focus on 3 axes and try to give an equal weight to these axes. Even if EPFL is a top engineering and technological school, we are not only developing innovative solutions to improve the safety, efficiency, and sustainability of vehicles and infrastructure. This is the supply-oriented side of transportation, but it's not enough. With only this, you do not solve all issues related to transportation. It's very important to focus on demand. So to understand mobility, to understand changes in mobility patterns, to understand changes in lifestyles, because there are new forms of mobility that have been created over the recent years that did not exist before. To start from mobility needs and from individuals for developing the right public action policies or the right mobility policies, to make use of all the new technologies that are there to measure in a precise way and cheap way mobility patterns, smartphone, GPS, Wi-Fi, Bluetooth, smart cameras, and all the technologies you can think about, that are technologies that are not designed initially to tell us about mobility, but that can be used for large-scale data collection. And then the system-oriented approach, because transportation is about finding a fit between demand, so the users, the people that need to be transported, or the goods that need to be transported, and the supply, so the infrastructure and the vehicle. And the system side is very important. To have an holistic view on transportation, to be able to optimize an existing system by getting rid of congestion in urban areas, or to be able to optimize the design of a new system. How to design a new bus line in an optimal way, how to design in an optimal way a car sharing system or a bike sharing systems, and then there's a policy side. How to design adequately transportation policies that are in line with housing policies, urban planning policies, land use policies, and so on. And this is really our strength to have this broad approach of transportation research. Now I'll show you a couple of concrete examples. So we're very active on the demand modeling side. So this is a project we had with Postbus. So Postbus is a subsidiary company of Swiss Post. So basically they are operating buses in all the peri-urban and rural areas in Switzerland, including the mountain areas. And what they wanted to do is to be able to model the mobility needs of people that are living in these low population density areas, to be able to model all the complex activity chains of these people throughout a given week, and then to quantitatively predict the demand both for new mobility solutions, so typically e-bike sharing systems that could be used in coordination with the bus system, but also for evaluating information systems. If I go more on the marketing side, we've been working with Renault, so one of the 2 French car manufacturers, to predict the demand and to predict the market shares for electric vehicles in Switzerland under various scenarios. And what we did with the modeling approach was to identify what are the target groups, so what are the subparts in the population that are the most likely to be interested in buying an electric vehicle. It was also about identifying what is the best pricing strategy, what is the willingness to pay to get a greener or a cleaner vehicle, what is the willingness to pay for associated services that could come along the purchase of an electric vehicle, and predict the demand for various services that could be provided by the car manufacturers. So this is more, I would say, the quantitative analysis and the quantitative prediction of transportation demand. Then we're also working more on the qualitative side with sociologists. So the first projects are mainly run by mathematicians. So now if we are going to the sociological side, we work a lot on what we call model shift. So how to change behavior. So what are the policies that should be implemented in order to reduce the dependency to private car and in order to foster model shift towards the use of public transport. And one of our labs has developed a so-called typology of the different mobility patterns, of the different type of people, based not only on the way they actually behave, but also based on the perception of transportation modes. And the key is to be able to account for the perception of the various transportation modes when analyzing the real mobility behavior. And then this type of methodologies allows us to identify and quantify the potentials for modal shift, depending on the context that is surveyed. Is it a matter of improving the commercial speed? Is it a matter of improving the safety? Of improving maybe making public transport cleaner, because in some cities they're not clean. So it's very important, and we are mainly running these projects either with cities or public authorities, or with public transport operators. Then we're also working a lot on lifestyle, typically with SNCF, which is the French railway company. Actually, they created 3 years ago a research institute focusing on mobility research that is called Forum des Vies Mobiles. So I would say Mobile Life Forum. And the idea is really to understand the links between lifestyle, residential choices, and mobility patterns. And now we are even including a fourth factor, which is the energy consumption in the household. And we are mainly focusing on new type of mobility behavior, long distance commuting or bi-residentiality. If you take the case of countries like France or Germany, almost 10% of the active population is either a long distance commuter or a bi-residential person. So these are, I would say, mobility phenomena that are not marginal anymore and that are becoming more and more important. And obviously the final goal and the ultimate goal of SNCF as a railway operator is to identify what are the new mobility solutions they should implement in order to fulfill mobility needs that are heterogeneous, because not everybody in the population has the same expectation in terms of level of services, in terms of comfort, in terms of travel speed, and so on. So this was for the demand side. For the system side, it's mainly about optimizing existing system or optimizing the design of new system. So when we're optimizing existing system, it can be to optimize simply a standard bus service. So here we worked with Veolia Transport, which is now Transdev. So it's one of the largest public transport operator that is active in 34 different countries worldwide. And here what we did is that they have one of the most used bus line in Europe. So the line between Nice and Monaco basically carries about 1.5 million passengers per year. So it's the fourth or the fifth most used bus line in Western Europe. And they have 3 different routes, so 3 different itineraries. And the idea was, thanks to advanced traffic modeling, to analyze the congestion patterns in a spatial way, but also in a temporal way, to re-optimize the design of the lines. So to know where should be the bus stop, also to account for the passenger, for the transportation demand, but to readapt at best the system while minimizing operating environmental cost. Why minimizing operating and environmental cost? Because if you are able to better understand congestion and to reduce the travel times over your bus lines, you basically need less buses to ensure the same headway. And if you need less buses, it means that you reduce the operational cost for the provider and for the cities, but you also reduce the environmental and the energy cost. And on some of the lines, we managed to increase the efficiency by 15 to 20% without changing anything. We are just basically readapting the system and its operational management. We're also working on congestion on highways. So here is a project with the Swiss Department of Transportation, because in Switzerland, departments are called Federal Office. We are working with the Federal Office of Roads to evaluate and simulate whether it would make sense to set up ramp metering strategies on Swiss highways. So you will tell me that ramp metering exists for many decades. It's highly deployed in the US, it's highly deployed in the Netherlands, but here in Switzerland, we need to account for some specificities. First of all, the ramps in Switzerland are very short. So Switzerland is a small country. Everything is small, including the ramps on the highways. But the second thing is that the highways go down to the heart of the cities. You have some exit highways that are really into the city center. So if you just control the incoming flows in a stupid way, you will just propagate the congestion in the urban areas, so upstream, which is already the most congested part. So here we have a more global, a more holistic approach where we combine ramp metering strategies for controlling the incoming flows on the highway with variable speed signs for controlling the flows that are already on the highways, plus a control of the traffic lights in the surrounding areas. So you need to have a combined highway traffic management and urban traffic management, because otherwise you just move the places where the congestion is the largest. Then we're also working on the design of new systems. So this is a nice project. It's called TOSA. So it's a new generation of bus. So basically, it's an electric bus, but without needing the catenaries. So basically, it's composed of supercapacitors and batteries. And the idea is to do sequential power supply at some bus stops. So you give pieces of electricity at some given bus stop so that you don't need anymore the lines for operating the buses. But the question was how to optimize the operational cost of such a system, how to optimize the global electricity consumption, and how to design the system. Where should we locate the charging station? For how long should we charge at each station in order to fulfill the timetable constraints? And again, the thing is that we are working on an applied project because we have a pilot study that is ongoing on a bus line between Geneva Airport and Geneva Hospital. And again, beside all the external funding that are brought by these external partners, the most important thing is data, because we are providing real data and real case studies. Here we are talking about more than 10 million that have been invested by ABB to build the prototyping bus, to build the prototyping line, and this is a case study you can have access to if you are just a university or just a research laboratory. So this is the thing we are the proudest about this collaboration. We're also working on car sharing, so both to analyze the optimal dimensioning, to identify the ideal location for implementing car sharing station in a station, and in a city, sorry. And most importantly, the question is how do you design and operate at minimal cost one-way system? So one-way systems are not loop systems. One-way means that you can take your car in a station A and leave it in a station B. The issue with this is that you need to manage the unbalancing of the vehicles among the station. And the question is how can we make it kind of automatic throughout a detailed analysis of the origin-destination demand and through dynamic pricing schemes. Typically in Paris, you probably all know the Autolip. It is not done at all. So basically, they are making use of human operators to rebalance the vehicle. It costs a huge amount of money. I will not tell you how much car sharing costs to the city of Paris, but we are talking about millions only in terms of operational cost and rebalancing the vehicle. So here the idea is to develop a decision aid tool that allows minimizing these balancing costs. We're also working on pedestrian. So this is again a nice applied project. So we equipped the train station of Lausanne. Actually, I don't know whether you came by train to EPFL, but the train station of Lausanne is equipped with more than 100 sensors. So these are cameras where we have embedded an automatic detection and tracking systems that allows extracting on a real-time basis the trajectories of the different pedestrians. So we are not violating privacy rules because we don't need to store the videos, we don't need to store the images. We just extract on a real-time basis the position of the person. So these are XYT coordinates. And then it allows us to do some diagnosis, to identify the congestion areas, to build some density maps and so on. And then we are doing simulation because all the goal of this project is to re-optimize the dimensioning of the train station under various scenarios, because between Lausanne and Geneva, the demand, so the number of passengers, is expected to double by 2030. The question is what should be the optimal dimensioning of the underground corridors, what should be the optimal dimensioning of the tracks in order to account for these passengers flow. And also to analyze the pedestrian strategies from a socio-geographical viewpoint. So to know how people decide to route within a station, how people decide to access to a train station. So this is again a multidisciplinary project because we are working with experts in computer vision, expert in mathematical modeling, and expert in sociology and anthropology. And this is an applied project because, again, we have a real lab for pedestrian modeling that is basically unique in the world because most of the scientists that are working on pedestrian modeling are making use of small mock-ups, typically in the corridors of a university. Here we have an entire train station as a gameplay for our scientists. So we have trajectories of more than 120,000 people per day. So this is really great. We're also working on intelligent vehicles, and by vehicles I mean all vehicles. So it includes unmanned aircrafts. So this is a project with Honeywell, so the aerospace industry. The idea is to develop detection and tracking algorithms, so for being able to detect and track surrounding objects, but also collision avoidance algorithms, so that once a collision potential has been detected, you need to decide on the optimal maneuver to avoid the collision. And we are making use of a small mock-up composed of quadrotors. So we first start with the algorithmic design, then we integrate the algorithms in a realistic simulation framework, and then we move from the simulation to the real mock-up. And this tells you a bit about the spirit of research at EPFL. We like to go up to the prototyping phase, up to the, obviously we will not commercialize the solution, neither the softwares, the algorithms, nor the system, but we want to make the test by ourselves and to be able to test our research work in real indoor and outdoor conditions. So this is important. This is a funny project where we are doing driver monitoring. And driver monitoring include the analysis of the emotional state of the driver. You probably know Dr. Ekman, who defined the face action units. Here what we made use of these, I would say, the 7 basic emotions he defined, and we developed a computer vision algorithms that allows us analyzing on a real-time basis the different characteristics of a face, so the eyebrows, the eyes, the nose, the mouth, to be able to predict the probability that the driver is in a given emotional state. So we are making use of these technologies for detecting stress, because we know that when a driver is stressed, he can have unsafe behaviors. On this project, we are also developing a fatigue detector, so to detect the fatigue based on the percentage of eye closure, based on the movements of the heads. We are also monitoring the distraction, or what we call guest detection, by eye tracking technology. So again, the idea is to be able to detect relevant emotional states in an automotive context. And what we did, so this is something that we are very interested in, is to build a virtual camera, because in a vehicle you cannot put a camera in front of the driver because otherwise he won't see the road anymore. So here what we did is that we are making use of a network of several physical cameras, with each of them having a different field of view on the driver, and we are rebuilding a virtual camera to emulate an in-front view of the driver. And again, the fact that we are using with a real car brings some complexities. We have limited computational power. You would be amazed our car is not very powerful in terms of IT. My laptop is definitely much more powerful than the whole system of a vehicle that controls the driving assistances and the HMIs. So we needed to adapt our algorithms so that they are able to work on a real-time basis with a limited power. We also have constraints regarding the location of the cameras in the vehicles. We have some cost constraints to account for because you cannot put super expensive cameras in the vehicle. So again, this is the third advantage of this collaboration. The first one is obviously money, because money is needed for research. The second is data sets, case studies. And the third one is ideas for research. And even if we started with a first tech transfer project to test our existing algorithms that had a given scientific maturity into a real context, the real context brought new ideas for research. And now we are running a new wave of PhD thesis. And I like this loop working mode. And then we have many other projects on logistics and so on, but I think it gives you at least a partial overview of what we are doing.
Thank you very much.
I'm done so that we have some time for questions, open discussions, or comments that are also welcome.
Yeah. Question, because we had a presentation just this morning from Jean-Philippe concerning this driver project. How which was the role of the center in that?
Mm-hmm.
It was center, was it a joint presentation? Was it how did it?
Yeah, that's interesting to explain about this because it basically explicits our working mode. So first of all, thanks to a work made by the Vice-Presidency for Tech Transfer and the Transportation Center, we managed to bring PSA on EPFL campus. So they opened in mid-2011 a so-called innovation cell to do some technological scouting. And then, obviously, even before arriving, we already had defined some key research topics they wanted to develop in collaboration with EPFL, and we already looked for relevant lab. And this is my daily goal, is to understand the needs from external partners and the competencies we have at EPFL, and to look for areas where we have a matching. So they had already met with Jean-Philippe Tirand when we were negotiating the possible venue of our campus. And then once the cell was officially installed, we rediscussed with the lab they met with before. And we directly came with this idea because it was a project where we had some scientific maturity in other fields. Because a spin-off of this lab has been created for marketing application to analyze how people are reacting to an advertisement. It can be a picture advertisement or it can be a video advertisement. And when I was personally at Nestlé, because I used to work for the research center of Nestlé located in Lausanne, we used this in a food context to analyze the acceptation of food by babies, because you cannot ask babies to fill in surveys. So actually we had some babies with their mothers, and we analyzed the way they were reacting to the food to define a liking score, and also to evaluate the ability to eat the food, depending on the size of the bowl meals and so on. So it's funny because we've been working on this on the research side for more than 10 years in food context and in marketing context, and we found a fit in the field of intelligent vehicles, because the car industry needs to make vehicles safer. But making vehicles safer is not only about having vehicles that are able to sense the surrounding environment. It's also make the vehicle be able to understand the driver and to know whether the driver behavior or the driver state is, I would say, in line or appropriate to a given driving context. So this is a standard, I would say, tech transfer, but that required to understand the needs from the car industry and the competencies that we had on the campus. And we started with the first 1 year project to end up with a prototype in a quite rapid way and to install it in a real car to demonstrate that it's actually working. And now we have a PhD thesis that is ongoing, so on a longer term project. So this is what I meant by closing the loop. And this is interesting. We cannot always expect that we will directly start with a 4 years project funding a full PhD, but this is also where we need to look for the synergies and for the potential for collaboration. But this requires some work, and I think this is why we are useful. When I say we, it's also include the team of André. I think the success of EPFL in having so many industrial projects, it's not only about the quality of our scientists, it's also related to the fact that we developed the ad hoc structures to facilitate this tech transfer, to manage this tech transfer. Again, from the IP and legal aspects down to the project management and the account management. You cannot expect that collaboration will just run automatically. And we try to be proactive, to go to external partners, to evaluate what are their needs, what are the future challenges, and how we can help them. So we try more and more to be bottom-up, and not only to answer to industrial visit we receive, because EPFL being pretty well known, we have many requests from companies who just want to do a visiting tour at EPFL. We try to be more and more proactive and starting from the research. What are the research ideas we want to develop, and identifying the partners to team up with for making this research happen. Yeah.
I have a question regarding human resources. One of the, at the stage of development of industrial and entrepreneurship, industrial collaborations in Armenia, one of the first issues is developing the human resources and competence skills for the kind of activity that you are doing. And so my question is, first of all, what is your background? How did you come to do this job? Because it's not a normal kind of career to follow, and it's not standard. And also, generally, first of all, personally for you, and also for other colleagues that are on your team, and what are the things that should compose the portrait robot,
Yeah.
the profile?
Yeah. Well,
Could you maybe repeat the question? So
Okay, for the camera.
For the camera,
Oh.
so that it's.
so the question was related, well, first of all, to my profile. So how I ended up doing this, and what are the profiles of the people in my team who are running the transportation center. I think first I'm usually using the analogy of a car seller. If you want to be a good car seller, you need to know about cars, but you need to know about the demand of the client. And if you want to do efficient tech transfer between academia and industry, you need to know a bit about both worlds. So you need to know about how the real world works, what are the constraints, what are the opportunities. You need to know about the code, but you need to know also a bit about academia and about the research environment. And in my case, I really have this mixed background. So I'm initially a mathematician, so I did a master in mathematics in Belgium, because I'm Belgian. Then I came to EPFL for doing a PhD in transportation modeling, and I also spent 1 year at MIT. And then I moved 4 years to the industry in R&D. So basically R&D of Philip Morris and R&D of Nestle. And then I came back to in this tech transfer role because they were looking for a sort of executive director of this newly created entity. So I have this mixed background. And in my team, I try to have this type of background as well. So I have a scientific journalist that is there to valorize and communicate our activities to a broad audience. I have some project manager that are there to help our scientists managing the project, meeting the deadlines, organizing and structuring the research work. I have a key account manager that is there more for the industrial relationships and for maintaining the relationships, for solving some issues and so on. So, and not all of them have a PhD. Actually, I'm the only one who has a PhD as the executive director, but the others have either a bachelor or a master. But we are really bringing external competencies. And if I can say something, honestly, such a unit would not work with scientists. Or I would say it should not be composed of frustrated scientists that are coming with the idea that they will do research together with the labs. We really need to be complementary to our labs. And this is actually the same at the Vice-Presidency. Andre also holds a PhD, so most of us hold a PhD, so we know about academia, we know about research, we know about the constraints in a research work, and we know what a lab can do, what a lab cannot do, what a lab wants to do and doesn't want to do, and this allows us finding the synergies between our capabilities and the needs of external partners. But it's a good question because it's hard to find this type of people, and you need to have, I would say, a system that valorizes this type of people that are not on the purely scientific track. So this is important, and this is also something EPFL has been successful in doing.
Follow-up question is, this team, did you recruit it all yourself?
Yes.
And so you had autonomy, you basically were
Yeah.
given this authority, and you were like, okay, this I'm going to build it from nothing.
This is an important aspect, to have a huge level of autonomy. So my boss, the VP for Tech Transfer, gave me a huge amount of autonomy. And yeah, I started from a white sheet. So basically I had to create a team. So it's like sort of creating a startup, but within a well-established institution. But this is what also made it successful. It's just that the two professors who initiated the idea and who negotiated with the direction to create this center already had an idea of where they wanted to go. But for all the operational aspects, I had to define it from.
So they trusted you, basically.
Yeah. No, it's important to give a lot of autonomy. And to all entities that are involved, to the labs. So we should not force the labs. We have 40 affiliated labs, but we do not force all of them to work with us. If they want to handle some industrial collaboration on themselves, they are happy to do it. And we should not try to be a super lab. So to try to impose what is transportation center research and what is not transportation research. So there should be a huge level of autonomy.
And when you recruit one of these people, what are the things that you look for? When you're doing a job interview, or when you did a job interview, what do you look for, aside from the background, the CV, but as personal qualities?
Oh, this is very important. The soft skills are really key. So very good communication skills, very good I would say, ability to deal with conflicting objectives, because in a way, a collaboration between academia and industry is always related to a gap, because you will never find a 100 match. So over the last 5 years, I initiated 80 industrial projects. There's always a gap between what our scientists would like to do in an ideal world, so basically take the money and do whatever they want, and the needs of the industrial partner that put the money on the table. So you need to be people that are able to listen, that have very good listening skills, and that are able to find trade-off. Because I want people who put themselves in an in-between situation. Even if they are EPFL employees, they should be able to understand the partner's viewpoint, to find out a solution. And we are really there to build this bridge. So not only in the initiation phase, but also when the project is ongoing, especially for longer-term projects. If you are talking about a 4 years project where you have some PhD students involved, it can be that at the beginning, everybody and all the involved parties are excited to start. And then down the road, you realize that what the industrial partner will get is not really what was his initial expectation. And these are things you need to manage, you need to discuss. And
how can you tell this from a 30-minute interview or 1 hour interview with one person?
Well, it's not easy, but you know, when you're recruiting someone, you're always taking a risk. Even a scientist, it's the same with a scientist. But no, it's not easy. But this is why usually I'm trying to recruit. Again, the first thing is people who know a bit about academia, so at least who holds a master. Hopefully some people who came at EPFL because they already know about the specificities of EPFL, because you know that each university has its own working mode. And then I'm looking for people who are curious, who are interested in innovation, and who want to learn. And I'm not looking for experts. You cannot be expert in all topics. I'm not expert in all the topics I talk about. I know enough to be able to evaluate level of synergies between industry and academia to explain them to a broad audience, but I cannot be an expert in all the fields covered by our 39 professors. So you need people who are curious and want to, it's a sort of constant learning. I'm not saying it's easy, but I think it's useful. If you want to do efficient tech transfer, I'm always saying that what we are mainly doing is, this is what I put in a previous slide, is minimizing the negative externalities of external collaboration. So in an ideal world, I would like our labs to only keep the good aspects. Funding, data, case studies, and to minimize the negative side. When you have reporting, you have some, to handle some crisis from partners when they are unhappy about something. And I think this is something really key.
How about external scientific collaborations? For example, in these projects, having partners from other research institutions. How does that work? Does it happen with external, with the European funding?
Mm-hmm. Yeah.
These companies, for example, PSA, they also work with some CNRS lab, and so you have a consortium.
Yeah.
Is it frequent? How does it work?
So my model, I would say that 80% of our projects are associated with direct funding, because this is what is ideal in terms of fixed cost to the grant, because you know that preparing a year project is associated with a huge amount of admin staff. So I like to do some direct funding, so to make sure that the partner will put himself the money on the table and to have a bilateral collaboration, because it makes everything simple, more efficient. It makes sure that the partner is committed, but we also have consortium-based projects. And here, in this consortium-based project, our role is mainly to inform our labs about the right trends. So to be well connected with EU, with some external scientific centers, academic centers, and to know about opportunities for project. And when we hear about a potential project, we make the connection to evaluate whether our labs would be interested in teaming up with us. So this networking is also important, to be connected not only with public partners and private partners, but also to be connected with external, with academic partners. But then it makes things super efficient. To give you a clear example, we submitted 1 month ago a Marie Curie project on crowd engineering. So everything related to the management of crowds and pedestrian flows. And we were contacted by Delft University of Technology. We are working a lot with them. And then, given that we are two active universities with a good academic network and industrial network, it was super easy to finalize the consortium. I said, oh, I will bring the Genevas airport, I will bring the Swiss railways, you will bring the Dutch railways, they brought University of Manchester, we brought another university, and then this is also something that is important. So we try to work as alliances with the well-known partners to create. It's not a club, but it's more to make sure that we are building on long-term partnerships where we know that there is mutual trust, mutual confidence. And typically this is why we have a Eurotech alliance with TU Eindhoven, TU München in Germany, and DTU Denmark. So we also like to build these alliances with, not having common contract, but common MOU and say, yes, we will try to work together and to build on our long-term collaborative tradition. And this makes everything easier.
This is one aspect that we'd like to catalyze with this project. There's already research and scientific collaborations between our main institutions. Some of the institutions are represented here and EPFL, especially Professor Dion. He actually showed a publication where there was co-authors from one of the institutions that are represented here. And except that most of these, all of these scientific collaborations are scientific. This kind of industrial networking path has not been exploited or explored sufficiently, and so I think that this is a good opportunity for transforming some of these scientific collaborations into more applied and industrially relevant collaborations, and this would be something that I think many Romanian institutions would be very interested in, because for them it constitutes an alternative source of income and everything you say, and just these collaborations are a great way to build that trust, like you say, which is, it takes time, and it takes.
Building relationships takes time. Now we see the positive side. We have some partners that invest millions at EPFL that provide us with huge amount of material, but it was built from year to year, from project to project, and it's important.
Thanks again.
You're welcome. It was a pleasure.